Hi. Today we're going to be looking at measuring output impedance of a tube amplifier. So this is the tube amplifier we're going to be testing. It's a ordinary EL84 push-pull ultralinear tube amplifier, so output power is around 15 watts per channel. And so what we're going to be doing is measuring the output signal level, loaded and unloaded in different configurations, to see what voltage we get, and then we'll look at the signals on the oscilloscope, and this we will then use to form the basis for the calculations we use to work out what the signal, or what the output impedance of the amplifier is. So let's turn on the signal, and we can see on the oscilloscope here that our output signal is around 1 volt peak to peak. So what we're looking at is the blue VPP trace there that's sitting around about 990 or so. And so what we're now going to do is, so the amplifier is completely unloaded. So what we're going to do now is I'm going to put this 2 ohm resistor across the output and observe the voltage that it drops to. So at the moment it's around about 1 volt VPP, and if I put the resistor on, it drops down to around about, it's bouncing, but let's say 435 VPP. So from 1 volt down to 435 millivolts VPP. Okay, now the amplifier has negative feedback. So the negative feedback has the effect of reducing the output impedance of the amplifier. But by how much? So let's work this out. Let's turn the amplifier off, and what we're going to do is get inside it and disconnect the negative feedback, and then we're going to repeat the test, and let's see what happens. So be very careful with tube amps, of course, because 1, they're heavy, and 2, they contain lots of high voltages inside. So this blue connector here, or rather this grey connector, I should say, is where the negative feedback comes in from the output transformers back into the input stage of the amplifier. So if we remove that, stash it somewhere safe, and let's just put our amplifier back together again, just enough so that it'll stay together. Okay, and the amplifier is running again, and we've got 1 volt on the output, peak to peak, again, just like we did before. And now we're going to use the resistor again, the 2 ohm resistor. And this time, when we put it across the output, I'm expecting to see the output to drop quite a lot lower than the 0.43 volts that we got last time. So, and we're connecting the load in now. 111 millivolts. Oh, my probe is not touching properly. 111 millivolts against, it's bouncing around a little bit, maybe 120 against 1 volt. Okay. So now I'm going to repeat the same tests across the 4 ohm taps and the 8 ohm taps with and without negative feedback, and then we can look at the results. With those measurements being done, we can now use the formula for a resistor divider to help us determine the output impedance. For recap, this is how a resistor divider looks, and the formula gives you the voltage at V2. There's the formula. In the context of an amplifier, it might be more helpful to think about it like this, where here's your output impedance,
here's your load resistor, here's your loaded voltage, and here's your unloaded voltage. Now, if we draw the formula using those names, we get a formula that looks like this. It's the same formula. But we want to make Z the subject of this. So first of all, let's swap these two parts around, and we get the formula that looks like this. Now all we need to do is remove RL from both sides, subtract RL from both sides, and we get our formula here. So let's plug our values in. 1 volt, 2 ohms, 0.435 volts, and then subtract the 2 ohms, and this is the figure we get, 2.6 ohms. So let's look at the measured output impedances then across all of the different configurations we tested. First of all, with negative feedback, on the 4 ohm tap we got 1.2 ohms, and on the 8 ohm tap 2.6 ohms of output impedance. Without negative feedback, 4 ohm tap gave us 6.7 ohms, and the 8 ohm tap gave us 10.5 ohms of output impedance. So that shows the effect of the 14 dB of negative feedback this amplifier has.
Now this is actually part one of a two-parter, because this amplifier is actually going to be taken apart and rebuilt using a different topology on the output. So we're going to be using a zero output impedance topology with this amplifier, which changes the way that the feedback is applied. It's done through some resistor, it's done through a resistor network, and consequently the intention of it is to lower the output impedance significantly from the measurements that we've made here today. So once the rebuild is completed, I'll do a part 2 of this video.